Hello everyone, welcome to our lesson. Today we are going to study about chapter 2 measurements 2, which is topic of grade 10 or form 2. So in this lesson we are going to talk about the micrometer screw gauge in details. So let's see what we are going to study here today. First of all, we are going to talk about the micrometer screw gauge. We define what micrometer screw gauge and for which purposes micrometer screw gauge is used. Then we talk about the structure of micrometer screw gauge. We talk about all parts and function of the parts. Then we explain what is the pitch of micrometer screw gauge. Then we talk about how to take reading by the micrometer screw gauge. Then we will see what is the zero error. We will see two types of the zero, positive zero error and negative zero error is there. We will talk about them. Then we solve some examples. Okay, let's start our lecture. Okay, so what is micrometer screw gauge? So this device is called micrometer screw gauge. Okay, micrometer screw gauge. So for what purpose it is used? It is used to measuring dimensions smaller than those measured by the vernier calipers. So the distance, the size of the object which we cannot measure by the vernier caliper because they are so small, for example, and diameter of the wire. Okay, diameter of wire. Okay, so which are very small, we can measure by a micrometer screw gauge. Okay, micrometer screw gauge. So dimensions small which cannot be measured by the vernier caliper, so we measure by the micrometer screw gauge. Okay, small diameters such as the diameter of objects and diameter of a thin wire can be measured by micrometer screw gauge. Okay, so for example, I have very small object, so I can measure diameter of this object by the help of micrometer screw gauge. Or I have very small wire, so I can measure the diameter of this small wire. I can find its radius as well. Okay, so the length up to millimeters we can measure by the micrometer screw gauge. So there are two types of micrometer screw gauge. This is mechanical micrometer screw gauge. So these are, you have to take readings. So this is digital. For example, I keep object here. Okay, I want to measure the diameter of this object. So I keep object here between these two parts. We will explain what are the name of these parts. So between these two parts, so here I will get the reading. Okay, no need to calculate. But this one I have to take reading. I have to find, calculate by the some formulas. Okay, but for digital micrometers screw gauge, it's on screen. Size of the object, of diameter of the object. So let's discuss about the structure of micrometer screw gauge. How is structure? So these are the main parts of micrometer screw gauge. This is called anvil. Let's start with the frame. This part is called frame, which is U-shape. Frame of micrometer screw gauge. Okay, this part is called anvil, and this part is called spindle. And here this part is called sleeve. Okay, and this is called thimble. This is called thimble. This is all called thimble, and this is called ratchet. This is called ratchet. These are the main parts of micrometer screw gauge. So for example, if I want to measure the object, the diameter of this object, let's say diameter of this object, So I keep between the anvil and spindle. Okay, object is kept between the anvil and spindle. Then I am going to see I have a main scale here. This is called main scale. In the sum book it is called sleeve scale. Okay, called sleeve scale. Here I have another scale. Okay, this is on the thimble, so that is called thimble scale. And here I have, this is called ratchet. Okay, so what are the functions of these parts? What is function of anvil? What is of function of spindle, sleeve scale or main scale, and thimble scale and ratchet? So here main scale is thimble scale is in the sum books it is called circular scale as well. Circular scale. Okay, circular scale as well. Okay, in the sum books it is mentioned the circular scale. In the sum books it is mentioned thimble scale. This is also called main scale or sleeve scale. Okay, so let's continue with the function of the parts. Okay, so the first one is what we said. We have a U structure. Okay, this U shape metallic structure is called frame of micrometer screw gauge. Frame of micrometer screw gauge. This is called, okay, you see, this is all called micrometer. The frame of micrometer screw gauge. Okay, this is all. Okay, then next anvil. We have anvil. So what is anvil? It is one of rigid measuring and holding point of micrometer screw gauge. So this is called what? Anvil. This is called anvil. Okay, we can hold the object from here. When object is kept between the spindle and anvil, so object is held from here. Okay, spindle. What is spindle? A cylindrical long part which is mounted through all other parts, sleeve, lock, nut and thimble. So the sleeve is, you see, it is between the, okay, this is the spindle. Okay, it's a long part up to the ratchet from here, then sleeve scale, okay, and then up to the ratchet. Okay, this is called, okay. And spindle is, it is movable. Spindle is movable. Okay, spindle can move inward and can move backward. When you keep the object, then spindle is moving inward and backward by the making rotation of tumble. When you make rotation of tumble, then spindle is moving inward or backward. Okay, spindle. Next one, structure of micrometer screw gauge. Structure of micrometer screw gauge. We continue with that. So anvil and anvil face and spindle face. These both faces are, okay, anvil and spindle faces, which are opposite to each other. Okay, and they are measuring points of the micrometer and hold the measuring object collectively. So actually, when we put the object here, it means that we are going to measure the distance between the anvil and spindle, because distance between the anvil and spindle is equal to the distance between the anvil and spindle is equal to the length of the object or diameter of the object. Okay, that is. So lock nut is after you put the object between the anvil and spindle. This is the lock nut. Okay, then you lock the system. Okay, when you lock the system, so spindle does not move. Okay, spindle does not move, then you can take your reading. Okay, then you can do your calculation. Lock nut is just blocking the system or lock the system. What is next part? So next part is what? The sleeve. Okay, so if you remember, we said this is the sleeve of, okay, this is the sleeve of micrometer screw gauge. This is the sleeve. Okay, so it is a barrel type cylindrical part which mounted on spindle, and it has a main scale of micrometer, because main scale is engraved on the sleeve. Thumble rotates around the sleeves and the spindle. Its main function is indication of reading in millimeter in case of imperial micrometer. So spindle is what? Spindle actually has a scale. So by this scale we are going to take readings up to the millimeter. How about thimble? So thimble is also mounted on the spindle and has a scale engraved around the perimeter of thimble. Scale of the thimble is to show measurements value in fraction. In fraction, so for example, let's say 2.5, 2.235. Okay, so these are the we can measure. So in the spindle thimble, this is thimble, and it has a spindle and it makes rotation. Okay, you can make rotation. By the rotation, the spindle is moving inward and backward. Then we are going to use on thimble also we have a scale. This is called thimble scale. For more accurate readings we use it. And let's talk about the main scale. So the sleeve has a linear scale in millimeters. This is the scale of sleeve. This is called main scale. Okay, this is called main scale, and it is in millimeter. Thimble scale has a circular scale of 50 equal divisions. So this is called thimble scale on the thimble. Okay, in the sum book, as I said, it is called circular scale as well. Main scale is called also sleeve scale. So let's go and talk about the pitch of micrometer screw gauge. So you see what we said, when I make one rotation, for example, I make one rotation of thimble. So when I make one rotation of thimble, so then we can say that the spindle is moving inward. Okay, spindle is moving inward, and this distance covered by spindle is called pitch of micrometer screw gauge. So distance is from A to B, let's say. So this distance is called the pitch of micrometer screw gauge. Okay, so I make one rotation. Okay, by the one rotation, spindle is moving, and distance covered by the spindle in one rotation of thimble is called what? The pitch of micrometer screw gauge. Okay, the distance moved by the spindle on one complete rotation of thimble is known as, okay, the pitch of micrometer screw gauge. Okay, so the spindle advances or retreats by 0.5 millimeter per complete rotation of the thimble. Okay, so per one rotation it covers distance of 0.5 millimeter. So how many divisions we have on main scale, thimble scale? We have 50 divisions. Okay, so each division represent of spindle travel of, so one rotation is 0.5. okay, how many divisions we have? 50 divisions. Okay, so then each division is 0.5 over 50 is equal to 0.1 millimeter. It means that each division has this make distance covered of 0.01 millimeter. So 0.01 millimeter is called the pitch of micrometer screw gauge. Okay, so hence if the thimble rotates through one division, the spindle advances by 0.01 millimeter or 0.001 centimeter. Okay, when thimble rotates through one division, so the distance covered is 0.01 millimeter. So total rotation makes 0.5 millimeter and one rotation make 0.01 millimeter, because we divide 0.5 by 50. So one division makes spindle moves by 0.1 millimeter. This is called pitch of micrometer screw. Okay, so now how to take readings by micrometer screw gauge. How to take readings. So first one is we place the object between anvil and spindle. Sorry. So I have object. I place the object between anvil and spindle. For example, you have a wire. You want to measure the diameter of wire. So you place the wire between the anvil and spindle. Okay. So the distance between the anvil and spindle is equal to the diameter of object. Okay. So second step is take the reading on sleeve scale or main scale. So let's take reading together. This is called sleeve scale. Okay. So you see here I see 0, 0.5, 0 I see 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5. So you see I see 5.5. Up to the 5.5 I can take measure reading on main scale up to the 5.5. Okay, so then it means that my main reading is what? 5.5 millimeter. Sleeve scale is 5.5 millimeter. Okay, check the line of thimble scale which coincides with the main line of sleeve scale. You see which lines coincide. Here I have the lines. Okay, these lines are belongs to the thimble scale. Okay, there are 50 divisions. So which line is coincides with the main line? This is main line of main scale. Okay, which line coincides? This is. Okay, so this is coincides. So then this is which one? This is which number? Okay, this is which number? So this is 30 and this is 31. Okay, so you see this 31 line of thimble coincides with the main line of main scale. Okay, so this is 31. Okay, I have found third step. So what is last step? Last step is multiply the line of thimble which coincides with the main line of sleeve scale by the pitch of micrometer screw gauge. So 31 is the coincides number, and multiply by pitch. Pitch is 0.01, so that is equal to 0.31 millimeter. 0.31 millimeter. So the coincides line, the line which coincides with the thimble line, which coincides with the main scale multiplied by pitch. Okay, so this is how to take readings. Okay, so what is total reading? Total reading is now, so let's go formula. So what is formula? Formula is, okay, the reading is equal to main scale reading plus thimble scale reading. Okay, what is thimble scale reading? Thimble scale reading is the line of thimble scale which coincides with the main line of sleeve scale multiplied by pitch of the micrometer screw gauge. Okay, pitch of micrometer screw gauge. Okay, so let's see what is example. So you see here I have example. Let's see what is the reading of, first of all you have to take reading of sleeve scale, isn't it? So you see this is 4, this line is 4, this is 4.5, this is 5, 5.5, 6, 6.5, 7. So up to the 7 I see on main scale, but 7.5 I don't see. It is under what? Thimble scale, I can't see. So it means that this is what? 7. So the main scale reading is 7 millimeter. Okay, main scale reading is 7 millimeter. So let's take thimble scale reading. So what is thimble scale reading? Line of thimble coincides with the main scale line, isn't it? So which line coincides? So this is 35, okay, 35, and this is 35. So this is 36, 37, 38, 39. You see 39 coincides with the main line. 39 coincides with the main line. So then we can say that, okay, 39 multiplied by pitch. Okay, so 39 coincides. So the 39 multiplied by 0.01 is equal to 0.39 millimeter. So what is total reading? Total reading is equal to sleeve reading, scale reading plus thimble scale reading. So the answer is equal to 7 plus 0.09 is equal to 7.39 millimeter. Okay, this is main scale reading and this is thimble scale reading. So let's see next example. Next example what we have. So let's do together again this example. So you see this is the 5, isn't it? So 0, 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. 5.5, 6, 6.5, 7 and 7.5. You see I see 7.5. Okay, so then main scale reading is 7.5 millimeters. Okay, let's see which line coincides. 20, 21, 22, 23, 24. Yes, 24 coincides. 24th line of thimble coincides with the main scale reading. Okay, then let's see 24 multiplied by micrometer screw gauge. Thimble scale formula is coincide line multiplied by micrometer pitch. So 24 coincides. 24 multiplied by 0.01 is equal to 0.24 millimeter. Okay, so what is total answer? answer total reading is equal to scale reading plus thimble scale. Scale reading is 7.5 and thimble is 0.24. So answer is equal to 7.74 millimeter. Okay. So let's see next example. What is next example? Let's do together again. So 3 IC 3.5 4 4.5. Okay, so the thimble main scale reading is 4.5 millimeter. Okay, so which line coincides? This is 30 doesn't coincide, 31 coincide. Okay, so you should 31. Then thimble scale is equal to line coincides and micrometer pitch. So let's find answer. 31 multiplied by, okay, 31 coincides multiplied by pitch is equal to 0.31 millimeter. So then total reading is equal to, again, slave scale reading plus thimble scale reading. So what is slave? Main scale is 4.5 millimeter and thimble reading is 0.31. So the answer is 4.81 millimeter. Okay, so let's see example 4. We have so many examples. This example is a bit different, you have seen, but you see between the each divisions there are each numbers there are 4 divisions, isn't it? You see 2.25, 2.5, 2.75, 3. Okay. Okay. So then you see 3.25, 3.5, 3.75 and 4. 7.25, 4.25, 4.5. Okay, then 4.75 and 5 I see. So same here I see 6 and 6.25 I see. 6.25. So it means that the main reading, main scale reading is 6.25. Okay, next one. Next one is which line coincides? Which one is coinciding with the main line? So let's read it. 11, okay, 11, 12, 13, 14. 14 coincides with the main line of, you see, there coincide. Okay, so 14 is the line coincides with the micrometer pitch. So then 14 multiplied thimble scale is equal to 14 multiplied by 0.01, which is equal to 0.14 millimeter. Okay, so what is the reading? Total reading. Total reading is equal to main scale reading 6.25 plus thimble scale 0.14. So answer is equal to 6. What is answer? 9.3. Here there is a mistake. Let's make correction. So the answer is equal to 6 and 3 and 9 millimeter. Okay, this is the answer of the question. Okay, let's question number 5. Let's take reading again. So here what we see the 0. Okay, this is 1, this is 2 and this is 3. So I see 3 but I don't see more on main scale. So the main scale reading or sleeve scale reading is 3 millimeter. Okay, so which number coincides? I have to go. So formula is same. Which line coincides with the main scale line? Let's see, 20 is there. 20 doesn't coincide, so 21. This is 21. So 21 multiplied by, sorry, just continue. 21 multiplied by 0.01 pitch. So this is equal to 0.21 millimeter. Okay, So total reading is equal to main scale reading, which is 3, and thimble. So let's see next example. So you see here, okay, on the main scale we just go and read 1, 2, 3, 4 and 5. 5.5, and you see I see 6 even. Yes, we can see 6 even. Okay, we can see 6 even. So then the sleeve or main scale reading is 6 millimeter. It's just touching. Okay, thimble is just touching to the 6. So that is what sleeve scale reading is, 6 millimeter. Okay, so what is next? Let's take which line coincides. That line is coincides. Which was that? 40, 41 and 42. This is 42. So 42 multiplied by pitch. Okay, this is thimble scale. 42 multiplied by 0.01 is equal to 0.242 millimeter. This is the thimble. Okay, so what is answer then? The sleeve scale reading plus thimble scale. So 6 plus 0.24. Answer is equal to 6.42 millimeter. Okay, so example 8. So we see which line coincides. This is 1, 2, 3, 2, 3. 3 point. You see this is also between the each numbers there are 4 divisions, isn't it? So it means that I can see. So this is 2, 2.25, 2.5, 2.3, 2.25, 2.75 and 3. So 3.25. 3 point. This is the equal to, this one is equal to 3.25 millimeter. Okay, so I can see the main scale reading is equal to 3.25 millimeter. So what is line? Which line coincide? It is also written. You see, you have seen. So this is 15 and this is also 16. You see. So 16 multiplied by pitch. Is it? So what is that? 16 multiplied by 0.01 is equal to 0.16 millimeter. Okay, so what is total reading? Total reading is equal to sleeve scale reading plus thimble scale reading. So that is equal to 3.25 plus 0.16. So the answer is equal to 3.41 millimeter. Okay, boys. And now we see a zero error of micrometer screw gauge. What is zero error of micrometer screw gauge, which we are going to study here? It arises, zero error arises when the zero mark of the thimble scale does not coincides exactly with the line of the sleeve scale when micrometer screw gauge is closed. For example, before starting to measure the object, so we close the micrometer screw gauge. Okay, so this is, let's say, anvil, and this is sleeve, spindle. So spindle and anvil should touch each other. Okay, spindle. So when spindle and anvil are both touching to each other, then we are going to check this scale. If zero line of main scale, zero line of thimble coincides with the main line of sleeve scale, it means that there is no error. But if they do not coincide with each other, zero line do not coincide with main line scale line of main scale, so it means that is error. So there will be an error in the measurement. Okay, so the zero error occurs when mark of thimble scale does not coincide exactly with the center line of the sleeve scale. Okay, so in the A there is no error. Okay, why in A there is no error? Because you see zero line of thimble scale is coinciding with the main line of sleeve scale. So there is no zero error, zero mark of thimble scale coincides with the center line of sleeve scale. So in A there is no error. Okay, so what is positive error? Zero mark of thimble scale is below than the center line of the sleeve scale. You see, this is zero line of thimble scale, and this is, let's say, the main line. It is below it. Okay, so this kind of error is called positive error. In the positive error, actually, for example, we know that object size or the distance or length which we are going to measure is, for example, is 5.55 millimeter. But I know this. Okay, for example, we know this. But if I am going to take a reading by this caliper which has positive error, okay, which has positive error, so it means that I am going to take a reading which is more than 5.5. Okay, 5 more, for example, let's see 5.57. okay, you see it is more than the actual reading. Okay, so that's why it is called a positive error. So then if there is positive error, what we do, if there is positive error, so positive error is subtracted from the main reading. It is subtracted from the main reading. Okay, so let's see negative zero error. Zero mark of thimble scale is above the center line of the sleeve scale. So you see this is the zero line of thimble scale, and this is the main line of sleeve scale. It is above it. Okay, so here we say there is negative error. If there is negative error, for example, if we know that the actual reading is 5.55, okay, so by the reading error, negative error, if you are going to use this vernier caliper which has negative error, let's say the reading will be 5.3 2 or let's say 5, for example. Okay, so you see the reading which we have taken by negative error micrometer, which has negative error, is less than the actual reading. Okay, so then what we do, so negative zero error is added to the main reading. Okay, we add to the reading, total reading. Okay, so this is negative error. So in positive error, the reading is more than the actual reading, that's why it's subtracted. If negative error, so then it means that the reading is less than the actual reading, so we are going to add the negative zero error to the total reading. How to take zero error of micrometer screw gauge? So you see in the first example there is no error, isn't it? There is no error because zero line of thimble scale coincides with the main line of sleeve scale, so there is no error. How about the positive here? In the second one, in B, as we have seen, it's positive error. So how to calculate this positive error? So you see the zero line is below the main scale line. Okay, so we are going to count numbers 0, 1, 2. So let's see, count the number of lines of thimble scale below the center line of the scale, okay, sleeve scale. Okay, so how many numbers we see? 1, 0, 1, 2. So the number below is 2, isn't it? So then what is the error? Error is 2 multiplied by pitch of micrometer screw gauge. Okay, 2 multiplied by pitch. What is pitch? 0.01. Okay, so then here error is equal to 0 plus means positive error. Okay, plus means positive error. 0.02 millimeter is the error of the millimeter is error of B. Okay, positive error. So let's see in the second one, in the C, count the number of lines of thimble scale below the center line, okay, line of the center line of the sleeve scale. Okay, so you see here the zero line is above the main line of the sleeve scale, isn't it? Yes. So how many? Let's count. 0, 1, 2, 3 and 4. Okay, so number is 4. Then 4 multiplied by pitch. Okay, minus is means negative 0. Okay, so 4 multiplied by pitch of micrometer screw gauge, 4 multiplied by 0.01 millimeter, which is equal to 0.04 millimeter. Okay, so in this A there is no error, in B 0.02 positive error, in C 0.04 negative error is there. Okay, so if you do calculations, so we subtract from the total reading minus 0.02, and if negative error is there by the C, okay, in C, so total plus 0.04. Okay, these are how to calculate. For example, I do this one. I have taken reading is 5.55. Okay, so I subtract this because there is positive error, so 0.02. So the answer is 5.53 millimeter. For example, I did by this one 5.55, so I will add 0.04, so 5.59 millimeter is answer. Okay, let's see the other examples. Next we have another example. So find the error of the micrometer screw gauge example. Okay, so what is zero error here? There is no zero error, isn't it? No, there is zero error. Which type of error is there? This is positive error because line is below, so 0, 1, 2, 3, isn't it? So positive error is, and the line coincide is 3. Zero mark of thimble scale is below than the center line of the sleeve scale. That is why there is positive error. There is a positive error. Okay, there is a positive error. So what is positive error? 3 coincide, isn't it? 3 coincides. Then let's find it. 3 multiplied by pitch. 3 multiplied by pitch is, answer is 3 multiplied by 0.01. So the answer is equal to 0.03 millimeter. So the positive error is positive error and number constant is 0.3. So 3 multiplied by 0.03 millimeter. 0.0, the answer is equal to 0.03 millimeter. For example, the reading which I am taking is 5 point, always we are giving 5, next change 7.25. Then I have positive error, so I will subtract it 0.3. So the actual reading is will be 7.2 and 3 milli 2 and 2 millimeter. Okay, answer will be 7.2 and 3 millimeter. Let's see another example. Another example is also find the error of micrometer screw gauge, isn't it? So there is no error. There is no error because main line and zero line of thimble they coincides with each other. There is no error. Zero mark of thimble scale coincides with the center line of the sleeve scale. So let's see this example. We have micrometer screw gauge, isn't it? So let's take the reading. Find the reading of the micrometer screw gauge. So if the positive error of micrometer screw gauge is 0.25 millimeters. So in this question, no need to calculate the error. Error is already given. Okay. So let's see which take my reading 1, 0, 1, 2, 3, 4 and 5 and 5.5. Okay. So the main scale reading is 5.5 millimeter. Which line coincides with the main scale line? So 40, 41 and 42. So 42 is coincides with the main scale line of sleeve scale. So you see 41 multiplied by 0.01 is equal to 0.42 millimeter. This is thimble scale. What is here? What we have? We have positive error, isn't it? If there is positive error, then we will subtract it. If you remember, so positive error is 0.025. Meaning of positive is here we say positive error. Okay, so we have to subtract it. So what is answer? Formula readings is equal to sleeve scale thimble scale minus positive error. Okay, positive 0 error. So 5.5 is main scale, 0.042 is thimble scale, and 0 error is 0.25 millimeter. So minus 0.25. So answer is 5.67 millimeter. So if you use this, you will find 5.67 millimeter. Okay. So let's see next one. Negative error. Negative error. If okay, negative error. If negative 0 error of the micrometer screw gauge is 0.02 millimeter. Okay, 0.02 millimeter. Okay, so what is answer? Answer will be sleeve scale plus thimble scale plus negative 0 error. Okay, so let's find answer. 5.5 plus 0.42 plus 0.25. because there is negative error, so we do addition. So the answer will be 6.17 millimeter. Okay, 1.67 millimeter. Okay. So next example. So in this example, example 2, find the reading of the micrometer screw gauge. So we have this reading. If positive, zero error of micrometer screw gauge is 0.28 millimeter. Okay, so let's go and see. First, we have to take the reading. Okay, so 1, 2, 3, 4, 5, and 5.5 and 6. So the main scale reading is 6 millimeter. Okay, so which number coincides with the main scale? 0 coincides, isn't it? So let's see thimble scale reading. Thimble scale is 0 multiplied by 0.01. Okay, so answer is 0.00 millimeter. So thimble scale reading is 0. So what is error? Error is 0.38 in the question it is given. So what should be total reading? Total reading is sleeve scale plus thimble scale plus positive error minus positive error. When there is positive error, so it's minus. So 6 plus 0.01, which is thimble scale, minus 0.838. So the answer is equal to 5.62 millimeter. If negative 0 error is there, and if it is equal to 0.38 millimeter. So what will be the answer? Sleeve scale plus thimble scale plus negative 0 error. So answer will be 6 plus 0 plus 0.38 millimeter. So the reading will be 6.38 millimeter. Okay. So these are micrometer screw gauge readings and how to find the 0 error. Okay, so next lesson we are going to study about the significant figures. Significant figures we are going to study standard form and prefixes and decimal place we are going to study. So we have finished our lesson. If you like, I want to remind these all details and the presentations, the videos you can find, and more assignments, example papers, questions you can find on www.ncdphysics.weebly.com. If you liked our lesson, please if you enjoyed the class, just like the lesson video and subscribe to our YouTube channel to follow us for next lesson. Thank you. Goodbye.